In this video, we're going to look at how to solve inequalities. So previously, we already talked about how to solve equations. So when we have an equation, we can do these four operations to get the variable unknown by itself. So for example, we can add a number to both sides of the equation, or subtract, or multiply, or divide. So these first thing we want to look at is, are these four operations still going to work when we solve inequalities? So most of the first two will still work, but the last two we're gonna have to modify them a little bit. So let's look at some examples here. So when we have inequality, 6 is greater than 4. So here I have made 6 copies of it. Now, when we do the first operation, which is to add a number to both sides of the inequality, so let's see if it changes the inequality. So as we can see, 6 is bigger than 4. After we add 2 to both sides, 8, we get 8 and 6, and apparently 8 is still greater than 6. So that this also makes sense, because if the left hand side is heavier or bigger than the right hand side, when you take away the same amount, the left hand side is still going to be bigger. So similarly, this also works for subtraction. So if we take 2, the quantity 2 or 2 pounds away from both sides, and the left hand side was still going to be heavier or bigger. So the first operation here, even if I change the equation to inequality, it's still going to work when we add or subtract a number to both sides. But what about a multiplication? So first, let's try to multiply by 2 both sides. And notice that 6 times 2 gives us 12, and 4 times 2 gives us 8. And 12 is still greater than 8. So it looks like when we multiply by 2, or we can, here we're doubling both sides. We could triple both sides, or quadruple, and so on. So it seems like when we multiply by positive number, it won't change the sign. But if I, let's say, if I multiply by a -1, and that's a negative number, let's see what happens. And notice the positive times a negative is negative, and positive times negative is negative. And apparently -6 is less than -4. So again, if you look at the number line, 6 is here, 4 is here, but when we flip to the other side, and the bigger number 6 actually is going to be flipped to the left side of -4, which makes it smaller. So what we need to pay attention is, when we multiply both sides by a positive number, we don't need to worry about the sign change. So it was still gonna, so this is a positive number, it's still gonna work. The sign, keep it. But if we multiply by both sides by a negative number, we have to remember to flip the sign. So greater than becomes less than. Now, the last operation we're gonna look at is division. So first I'm gonna try to divide both sides by 2. And we end up with 3 and 2. And again, 3 is still bigger than 2. But if I divide both sides by -1, you can also divide by -2, and it will still be the same result. So notice that -6 is less than -4. So again, when we multiply or divide by a positive number, not negative, and the sign does not change. See, greater than will still be greater than. But when we multiply or divide a negative number, and the sign must change. So we have to reverse the sign from greater than to less than, or less than to greater than. So now let's look at the properties here. So we have, so the first one, add and the subtract, they're not going to change the inequality sign. And for multiplication division, if we're multiplying positive and negative, and we are not going to change the inequality sign either. So these last two are different. So we need to pay attention to these two cases. When we either multiply or divide a negative number, the inequality sign must be reversed, which means greater than becomes less than, or less than becomes greater than. Okay, so let's look at some examples. And so when we solve inequalities, it's gonna be doing exactly the same things we did before as we are solving an equation. So I want to get x by itself, and there's 8 times, so I'm going to divide both sides by 8. Now notice that, so again, addition, subtraction, no worries at all. Multiplication, division, we have to look at the number we are multiplying or dividing. Since here I am dividing a positive number, 8 is positive, no worries. So we don't have to flip the sign. We keep the sign, greater than, greater than. And after we divide both sides by 8, 32 divided by 8 gives us 4. So that's the answer. But if we have a negative 8 in front of x, and notice that in order to get rid of negative 8, so we have to divide both sides by negative 8. And then whenever we divide a negative number, we have to remember to flip the sign. So less than becomes greater than. Now, after we solve the equations, we want you to write the answer in interval notation. So I am going to talk about what an interval notation is. Now, previously we learned how to graph an inequality. So when we get the solution x greater than 4 or x greater than negative 4, and we want to graph all the numbers greater than 4. So we first found where 4 is, and greater than 4, that means it's all the numbers to the right. If you have a highlighter, you could just start from 4 and highlight everything to the right, but make sure you use an open circle at 4 because it doesn't have an equal sign. It only has a greater than. So this is the graph. Same thing here. If it's negative 4 and we just found the negative 4 and draw a line, and that indicates all the numbers to the right. Or if you have a highlighter, you could highlight all the numbers. Now, so what is an interval notation? And this is usually used in a high-level math class, statistics class, or a calculus class. It's an easier way for us to write all these numbers, to indicate all these numbers. So the way we do it is, so we're going to write down the interval notation, of course, looks like an interval, and you can see the answers look like an interval, like a line segment. So we have we found the left end of all these highlighted numbers. As you can see, this is the left end, and which is 4, so write down the 4, and use a comma to separate, and then we try to find the right end. And notice that there's not really a right end because it goes on forever. So if it goes on forever and it doesn't stop, we use a negative infinity to indicate this. I'm sorry, this is a positive infinity to the right. Because as we move on to the right, it gets bigger and bigger and bigger. So, like 100, 1,000, 1 million, 1 trillion, 1 billion, 1 billion, 1 trillion. So it gets bigger and bigger. And we use infinity to represent the sort of like the end. Okay, so now we put them together in a pair of parentheses. So there is a place we need to be careful. For infinity, we always use parentheses, the round parentheses. But for the left end here, 4, it depends whether we have open circle or closed circle. If we have open circle, we use the round parentheses. But if we have a closed, we're going to have to use a bracket. Okay, so let's look at this case. Will be very similar. So I write down the left end, which is negative 4. The right end, there's nothing, so it's positive infinity. So this is what we call interval notation. So you have to indicate what's the left end, what's the right end, and so the answer would be any number between negative 4 and positive infinity. So let's look at another example here. So this is the one in this section what we're going to talk about today to solve inequality. Now this is the problem we did previously, how to solve an equation. And what we did before, in order to get x by itself, first we get rid of plus 7. We're reversing the operation plus to minus. And then in order to get rid of this 3, we reverse multiplication, and which is division. So we use division both sides. So we got x equals 4. Well, to solve inequality, so notice that we have a less than, not an equal sign anymore, but the steps are going to be exactly the same. So first, we still get rid of 7, subtracting. Second step, we get rid of 3, dividing. So we got x less than 4. So as you can see, and if you know how to solve equations, and you can just do exactly the same thing when you solve inequality. But we do have to pay attention to the symbol, the sign we're using here. So for equation, it's equal, equal, equal from the beginning to the end. For inequality, if they give you less than, you're going to keep it from the beginning to the end most of the time. The only time you have to flip it is when you divide or multiply by a negative number. So next, let's look at how we write down the interval notation. For equations, we never had to do this before because there's only one answer, which is the number 4. So if you really want to graph it, that's just the 4. So usually this is not necessary. So we never had to graph the solution of an equation. But the answer of an inequality, because it has many, many numbers, all the numbers less than 4, all numbers less than 4. So there are a lot of them. So if we can graph them, it will look very clear. So first we found 4, and numbers less than 4 will be starting from 4. Again, we dig a hole for throw the 4 out because x is not equal to 4 here. And so this is all the numbers. If you have a highlighter, you could highlight those numbers. And now we use the interval notation, which the left end, so we don't need to write down, always start from the left end. And then we have the right end. So the left end, because it goes on forever, so we use negative infinity to represent the left end. And the right end, it stops at 4, so we write down 4. Again, there's no equal sign, and we use a round parenthesis. And next, so in this example, again, the left-hand side is a equation, and the right-hand side is an inequality. So we can go ahead and just look at the inequality. So we get rid of 3, and we subtract. And notice subtraction doesn't change the inequality sign. And then we get rid of -5 and we divide. So since we're dividing both sides by a negative number, we have to make sure we flip the sign. So we flipped it from greater than equal to less than equal to. Now, when we graph the solution, so we first found the number -7/5 here. And because we do have this little equal sign, so we're going to use a closed dot. And less than means all the numbers to the left. So now let's look at the interval. So the numbers, all the numbers on this line from or on this interval are the solutions. So first of all, left end is negative infinity. The right end is negative 7/5. But since we have a closed dot or we have a equal sign, we have to use a different symbol to indicate that. So again, round parenthesis means when not the number is excluded. So here, like the previous example, that means 4 is, when we see round parenthesis, that means 4 is excluded. But if we see a bracket, that means negative 7/5 is included. So graphically, we use closed dot. Actually, you could also, I mentioned in previous video, you could also use a square bracket.